Good evening everyone and welcome back to my channel for the part 2 of our chapter acid, base and salt, class 10 CBSE. In the previous part we have first learned what acid is, what is base is, and we have tried to understand the different types of natural and synthetic indicators that are used to determine whether a chemical or a substance is an acid or base. And we also understood that how metals react with acids and bases. Whenever an acid or base reacts with a metal, there is an evolution of a hydrogen gas, which in turn is tested by the pop test by bringing a candle near the bubbles, of hydrogen gas, and the bubbles burst with a pop sound, which indicates the presence of the hydrogen gas. Now, let us proceed further and see how do metal carbonates and metal hydrogen carbonates react with acids. For this, again, we need a stand, a cork, a thistle funnel, and we put a compound as known as sodium carbonate because it's a metal carbonate and we want to determine how a metal carbonate, sodium carbonate, is reacting with an acid, a strong acid such as HCl, hydrochloric acid. So Ne2CO3 plus 2HCl, and this reaction yields salt, 2NaCl plus H2O plus CO2 gas is released. So in this process, CO2 gas is released. So we are taking some 0.5 gram of sodium carbonate in test tube A and 0.5 gram of sodium hydrogen carbonate in test tube B, and we are adding 2 ml dilute HCl to both the test tubes. Okay, CO2 gas is produced in both the test tubes. The first reaction which we are doing is in test tube A. Herein, in sodium carbonate, we are pouring hydrochloric acid. We are getting 2 NaCl salt plus H2O plus CO2 gas is liberated. And in test tube B, we are testing sodium hydrogen carbonate, and we are putting acid onto it, and we are getting salt NaCl plus H2O water, and CO2 gas is released. Now, how do we test the CO2 gas? CO2 gas has a very, carbon dioxide gas has a very simple test. It turns lime water into milky. So CO2 gas turns lime water milky. Now let's move ahead past CO2 through lime water. Lime water is calcium hydroxide solution. See, bubbles. This is a calcium hydroxide solution. Through this, CO2 gas is passed and it turns the lime water milky. Lime water turns milky. Lime water is CaOH2, aqueous. See, calcium hydroxide solution CaOH2 is known as lime water. Through this, we are passing CO2, carbon dioxide. It is turning it milky. A white precipitate of CaCO3 is formed, calcium carbonate along with water. On passing excess CO2, now another question comes. What happens if we pass excess CO2? On passing excess CO2, lime water becomes clear again due to the formation of soluble calcium bicarbonate. Now, what has happened? First, calcium carbonate is formed. Now, when you have passed extra CO2, excess CO2, CaCO3 plus H2O plus CO2, again, calcium bicarbonate is formed, and this is not milky in color. So again, the water becomes clear. So I hope the concept is also clear, that when metal carbonates and metal hydrogen carbonates are reacting with acids, we are getting the evolution of carbon dioxide gas, which in turn is being tested by passing it through lime water, and it is turning lime water milky due to the formation of CaCO3, white precipitate. And if we pass extra CO2, then the white precipitate again becomes clear because the formation of soluble calcium bicarbonate takes place. I hope the concepts are cleared for all my students. Now let us move ahead and see how, and just try to learn more conceptual things. See, this is a limestone, students, and this is a chalk. This is the marble. Limestone, chalk and marble are different forms of calcium carbonate. They are all CaCO3. They are different forms of calcium carbonate. All metal carbonates and hydrogen carbonates react with acids to give corresponding salt, CO2 and water. This is the conclusion. Metal carbonate, metal hydrogen carbonate plus acid gives you salt, carbon dioxide plus water. Now let's move ahead. How do acids and base react with each other? Now this is another important concept. How are acids and bases reacting with each other? Acids and base react with each other, and this reaction is known as neutralization reaction, an important reaction, and it is mostly asked in the examinations. So first we are taking 2 ml dilute NaOH solution in a test tube and adding 2 drops of phenolphthalein solution. The solution becomes pink clear. This is due to the presence of base NaOH. To this we are adding dilute HCl solution drop by drop. The pink color changes and disappears. Now add few drops of NaOH. Now we are adding few more drops of NaOH to the above mixture. The pink color of phenolphthalein reappears. The effect of a base is nullified by an acid and vice versa. This is what it is trying to explain. So what happens in this reaction? How do we show it? NaOH, sodium hydroxide, a strong base, reacts with hydrochloric acid, a strong acid. There is a formation of a salt. NaCl is a salt, plus water is formed, H2O. The reaction between an acid and base to give a salt and water is called neutralization reaction. So base plus acid gives you a salt plus water. Now let's go ahead. Reaction of metallic oxides with acids. Now dilute HCl is our acid. Metallic oxide can be CuO, copper oxide. So what is happening? Take some copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. So see, the color has changed, green. The copper oxide dissolves and the solution becomes blue-green color due to the formation of copper 2 chloride, that is CuCl2. CuO plus 2HCl gives you CuCl2 plus H2O. General reaction between a metal oxide and an acid is metal oxide plus acid gives us salt plus water. Okay, metal oxide is CuO is reacting with acid, it gives us salt and water. Okay, the salt is CuCl2, that is bluish green in color. Metallic oxides react with acids to give salts and water, like the reaction of base with an acid. So metallic oxides are basic oxides. Okay, fine. What did it say? It's an important paragraph. I'll read it again. We have neutralization reaction, base plus acid, and that yields us a salt plus water. Same way, a metal oxide is reacting with acid and giving us salt and water. So what it says is that metallic oxides also are basic in nature. They are basic oxides. That's why they are reacting with acid and giving us salt plus water. Now let's go ahead and see the reaction of a non-metallic oxide with base. Now we have CaOH2, calcium hydroxide, being reacted with CO2. It's giving CaCO3 plus H2O. Calcium hydroxide base reacts with carbon dioxide to produce salt and water. Okay, yeah, this is similar to reaction between a base and acid. It means non-metallic oxides are acidic in nature. Here we have seen a reaction of a non-metallic oxide with that of a base. Okay, and the base is calcium hydroxide. Calcium hydroxide is the base. It is reacting with carbon dioxide, which is a non-metallic oxide, to produce salt and water. CaCO3 is the salt, calcium carbonate and water. This is similar to reaction between a base and a acid. It means that the non-metallic oxide is acidic in nature. So what we need to remember, metallic oxides are basic in nature and non-metallic oxides are acidic in nature. Now let us move ahead and see that what is it that all acids and bases have in common. All acids and bases generate hydrogen gas on reacting with metals. So hydrogen seems to be common to all acids, but all compounds containing hydrogen are not acidic, and this is being proved by an experiment wherein we are taking solution of glucose, alcohol, HCl, H2SO4, etc. We are fixing 2 nails on a cork and placing it in a 100 ml beaker. Connect the nails on the 2 terminals of a 6-volt battery through bulb and a switch. Pour some dilute HCl. In the beaker, switch on current, repeat with dilute H2SO4. In both cases, bulb glows. That means that both dilute HCl and dilute H2SO4 are good conductors of electricity. They have conducted electricity. In both cases, bulb has glowed. That means electric current passes through the acidic solution by ions without much difficulty. So which ions? H plus ions. Repeat this experiment using glucose and alcohol. In these cases, bulb will not glow because glucose and alcohol solutions will not conduct our electricity. Acids contain H plus ions as cation. Cation is positive ion, and anion Cl negative in HCl, NO3 negative in HNO3, SO4 2 negative in H2SO4, CH3COO negative in CH3COH. Acidic properties are due to the presence of H plus aqueous ions in solutions. So repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide, etc., NaOH, KOH, and will conduct electricity as they are broken down into ions when dissolved in water. Movement of ions Na plus, K plus, and OH negative in solution generates electricity. Okay, so they ask this question in exam that why acids are generating electricity, the bulb is glowing, and not for glucose and alcohol, because acids contain H plus ion as cation, anion, and Cl negative. They are able to conduct electricity through their solution, and the bulb is glowing. But this is not the case for glucose and alcohol. Now, let us see what happens to an acid or a base in a water solution. Acids produce ions only in aqueous solution. It can be proved by an experiment. Now, first we are taking 1 gram solid NaCl in a clean, dry test tube. NaCl is salt. To this we are adding some concentrated sulfuric acid. This is your sodium chloride in a test tube. This is a pair of tongs. So this is a dropper containing concentrated H2SO4 being dropped in the solution. HCl gas comes out of the delivery tube in very humid climate. So we are passing the HCl gas through a guard tube, drying tube containing calcium chloride to dry the gas. And this is a moist litmus paper. So the acid has turned the blue litmus paper red. Okay. Now when HCl gas is tested with wet blue litmus paper, it becomes red color, but with dry litmus paper no color change happens. This question is asked in exam, but that why with dry litmus paper no color change occurs. It means dry HCl gas has absence of water, cannot produce H plus ion, so it does not behave as an acid. HCl solution in the presence of water can produce H plus ions and behaves as an acid. HCl plus H2O gives you H3O plus Cl negative. H plus ions cannot exist alone. They exist after combining with water molecules. Thus, H plus ions must be shown as H plus aqueous or hydronium ion. Hydronium ion is a much more correct terminology for the H plus ions of acid. So, hydronium ion H3 plus H3O positive and H plus. So, how is H3O positive being formed? Due to H plus ion reacting with water in aqueous solution, acids yield this hydronium ion H3O positive. So as of now, students need to understand that acids contain H plus ion, and on getting water mixed into it, on becoming an aqueous solution, they yield hydronium ion H3O positive. Okay, so what happens to an acid or base in water solution? Bases, what will bases generate? Bases will generate hydroxide, OH negative ions in water. All bases do not dissolve in water. Bases which are soluble in water are called alkalis. NaOH, KOH, MgOH2, NH4OH, etc. Alkalis are soapy, bitter, and corrosive. Never taste or touch them as they may cause harm. So now we see NaOH solid. When H2O is mixed into it, it yields Na plus aqueous and OH negative aqueous, which is a hydroxide ion. Same with KOH, K plus aqueous and OH negative aqueous, MgOH2, Mg2 plus and 2OH negative aqueous. Okay, and what happens to acid base in water solution? The neutralization reaction between acid and base can be represented as follow. Acid plus base is salt plus water. Okay. So we keep the this video till this point.